All right, we're on the last tab, t-test two sample dependent groups. Where before the previous tab was two sample independent groups. This one, there is some sort of dependency between the two groups. In this case, the scenario is we have two editors are currently being used to review reports to test to see if there's a difference between them. 10 reports were given to both, and the number of errors reported for each one. Is there a difference between the two editors? Okay. So state my null, my alternative. My H naught is going to be editor 1 is the same as editor 2. My alternative editor 1 is not equal to editor 2. We'll use the 95 percentile, my decision rules. All right. So we failed to reject if greater than 0.05 and less than 0.05, we reject the null. Okay. So we go to my add-ins, Megastat, hypothesis test, paired observations. We have data input, group number 1, so editor 1. Group number 2. Again, don't forget to highlight, well, first off, all the data and the label. And I can quickly just change that by changing that number up there. Alternative is not equal. Hypothesized difference, 0. It's going to be a t-test. Looks good. We push OK. You also notice that there's not this additional pooled variance versus unequal variance with this one. So there's not that additional test. All right. Now it's kind of hard to see, but it is slightly different color here. It's a light yellow, 0.04 p-value. Okay, so you have to watch that. So it looks like the mean is 12 for editor 1, 8 errors for editor 2. Standard deviation is mean difference about 4. Standard deviation is 5.3. So it could go by either way. And 0.045 is our p-value. So 0.0 or 0.04, what was it again? 0.05. Is less than 0.05. Therefore, reject the H naught. In this case, it's really close. On this one, it would be a toss-up. I would actually probably, if I was trying to make a decision between the two of them, give them a second round of tests to see if there is a difference between them, because 0.045 rounds up to be 0.05 and it becomes part of that gray area of whether or not we reject the null or not. But in this case, technically speaking, we do reject the null hypothesis, meaning that they are not the same. There is a difference between the editors. And going back to my output, it looks like editor 1 has more errors than editor 2. But the p-value is so close. Hard to say one way or the other. because sometimes this happens in the real world where you want a really secure, nice, here's the result, here's what it's going to be, but you get a result like this one where it is really close and it's hard to say one way or the other. Technically it is below the 0.05, but if we use the 0.01 or 99 percentile, we would fail to reject. If we use the 90% confidence interval or 0.1, we would reject the null with a lot better ease. So this is where it becomes very important to understand some of these gray areas, and sometimes you just can't say definitively one way or the other because sometimes it's really, really close. So the solution to this one would be to set up a second round, maybe a new set of reports, see if they show up any different, include them in the previous data, and test it out. All right, this concludes the t-test and z-test videos.